Okay, so welcome everyone to Guided Study Group Week 4 of Statistic 100. So as usual, we're gonna go through the materials, and this week it's gonna be lesson 5. However, there's another session this week, which is this Sunday at 9 p.m. So this is a Sunday right before the exam. So I would have kind of like a quick like an exam review of the materials that we've learned so far from lesson 2 to lesson 5, and kind of like get you guys a little bit more ready for the exam next week. And so there will be another session this Sunday 9 p.m. as I say, and there'll be no sessions next week. Yeah, because it's like exam week and there's not any new materials anyway. So let's get started with lesson 5. So lesson 5 is bell shape, curve, and statistical pictures. So kind of like start to familiarize yourself with the concept of standardized scores and normal distribution and all of that. So the first part is standardized scores. So basically it's just giving us, so say they give you, okay, the value of mean and standard deviation, and they give you the value that we're talking about right now. And the standardized score is just giving you like a bigger pictures of how far that value is from the mean based on the standard deviation. And so to find the standardized score is going to be that value minus mean divided by standard deviation. Honestly, in this class, as I say, you guys wouldn't have to do that much of calculations at all. So this shouldn't be a problem. We're mostly just gonna like get the result from maybe you given the result, and you just mostly of this class is just like interpret the result. And so standardized scores is if you have the value equal to the mean, obviously you have like a 0 numerator. So if it's at if that value is a mean, the standardized score is gonna be 0. The standard deviation is always 1. So say if you have like a value like 1 standard deviation away from the mean, then it's the standardized score is going to be 1. So yeah, that's when you have positive z, it's going to be a number bigger than the mean, and if it's negative, it's going to be smaller than that. So yeah, that's standardized scores. So it's just like kind of like quantifying you like a relative standing on the list of like how many standard deviations are you above or below the mean. Then we have something called the normal curve. So the normal curve is depicted as like a curve with bell shape, like this one, and it's symmetric. So bell shape and symmetric, and it show a normal distribution in the sense like you're gonna have less distribution, lower frequency at the two ends, and more as it gets to the middle. And so the mean for a normal distribution, so it's like a symmetric and bell-shaped one, is gonna be approximately the median. The percentiles, the relationships between percentiles and standardized score is gonna be given in table 8.1 in your book, chapter 8. So feel free to look at that if you have some questions relating, like they give you the standardized score and they're asking for what percentile it is, or asking the other way around, then you know how to answer it based on this table. Then we also have the empirical rule. So kind of like a general shape of the bell-shaped normal distribution is that it's giving us 68% within the distance from mean minus from 1 standard deviation below the mean to 1 standard deviation above the mean. And the percentage is going to increase as you go further and further. And this is the most important one. So between mean minus 1 standard deviation and mean plus 1 standard deviation, you're going to have 68%. Usually, if it's a normal distribution, you're going to have 68% of the populations in there. And between mean minus 2 standard deviation and mean plus 2 standard deviation, you're going to have 95%, and it goes on to 99.7 for the case of 3 standard deviations. We also have some way to kind of like represent the statistical data. So the basic features of these display is that it clearly demonstrates the data on it. So compared to a table or just putting out the numbers on it all and like a bunch of numbers together, these kind of data display is arms to like represent our data much better, and it just communicate information much quicker. So it has so that display should be clearly recognizable from the background. So it shouldn't make the job more difficult, because then there's no point to do data display at all. Clearly labeled to kind of like give anyone who have no idea about what's going on still be able to find some directions and navigate through that graph. Yeah, title, purpose, origin of data, variable, scale, and all of that. Then we need just like a minimal amount of extra. So if you want to make any note, put it on the side of the graph or like right below it, but do not push like all the thing on the graph, because it's gonna make it more complicated. And again, it go against our initial purpose is to communicate that data easier and quicker. So there are multiple ways. First one, we have bar graph. So bar graph is usually representative data of categorical variables. So things that you answer either like men or women or yes or no, or like what party do you vote for, like Democratic or like Republican, all of that. Yeah, and then it's usually easier to compare data of groups. So look at the graph here, you have like different groups, like you have two groups, men and women, and you compare it between countries. So it's kind of like showing you a very clear trend and kind of like each portion compared to one another, and it's still distinguished between men and women. So that's bar graph. We also have two other graphs called the time series plot and scatter plot. So the time series plot allow us to see like the trend, and it usually applies for like stock market or thing like if you want to talk about demand and supply, and you want to see like how the price fluctuated, or kind of like maybe like things like inflation rate. So it's actually just work better for the trend. We're trying to also looking for things like seasonal components, cycles, or patterns, and most of the time we want to like compare different time series plot together to maybe draw some conclusion about like maybe what is this cause, like what's the nature of it that it create this fluctuation. The last thing that we have here is the scatter plot. So scatter plot is usually used to represent the relationship between two quantitative variables, and this is because of the fact like usually scatter plots is used to show like if any two quantitative variables can relate to one another, or one can cause another, depending on like how you obtain that data. If that data is obtained by things like randomized experiments, so you can actually draw like a causal relation from it. But if it's from something like observational study, we can use scatter plot to say there's an association, but not necessarily one causing another. Yeah. Just like this, and remember it's only applied for two quantitative variables. So if you have a categorical, scatter plot is not a very good options to choose from. Yeah, so that's most of the materials that I have. And again, if you're following me online, feel free to stop me if you want to work on these problems alone, because I'll just like give out the answer immediately since no one's actually joining me online, so there's no point of waiting. So the first question, which of the following is true? It's asking, so if you look at the answer, most of the thing is related to how a distribution look like and where you have the median and the mean. So first of all, when you have if a distribution is skewed to the left, the median will typically have a negative standard score. So if it's skewed to the left, it's like this. And if it's the other B is if it's skewed to the right. The median will typically have a negative or positive standard score. So okay, so first look at the distribution that is skewed to the left. We have the standard score. That's my abbreviation for that. Standard score is equal to the value of that number minus the mean divided by standard deviation. Now, the thing that we're talking about here is the median. So it's going to be median minus mean divided by standard deviation. Now, we have to determine if this expression is negative or positive. We have an always positive denominator, which is standard deviation. So all we care about is the numerator here, the median minus mean. Is it positive or is it negative? Now, it's different depending on the distribution. So if you have a distribution that is skewed to the left, then you're going to have the median actually bigger than the mean, because the median is here, because the mean is more sensitive to the smaller number. So because of this small tails on the left, then you're gonna have the mean is gonna be shifted slightly to smaller than the median, because as we said, the mean is more sensitive to those extreme numbers. So the median minus the mean here is actually bigger than 0. So it should have a positive instead of a negative standard score. So this one is wrong. And similarly, if you do the same thing for distribution skewed to the right, then you're going to have the mean, delete that. You're going to have the mean slightly bigger than the median. So here you're going to have median minus mean is going to be a negative number. So this is a negative, so this answer is also wrong. So let's see if a distribution is symmetric, like this. We have the median is approximately the mean. So the median will therefore have a standard score of 0, because median minus mean is now approximately 0, and the entire standard score is just going to be 0. So C is the correct answer. Now we go to question 2. Again, stop me here if you want to work on this problem alone. Suppose the weights of women are normally distributed within a mean of 100. So mean is 180 pounds, and standard deviation is 13 pounds. About 95% of weight of the women. So if we already given that the distribution is normal, therefore we can use the empirical rule to solve this question. So here we have 68, 95, and 99.7. So the interval that fit with 95% of the population is where you have mean minus 2 standard deviation to mean plus 2 standard deviation. So it's going to be 180 plus or minus 2 multiplied 13 pounds. So B is the answer. And so this is, you don't even need to look at the answer choices before you do this, as long as you understand what you have to use here, which is the empirical rule. And remember, you need the distribution to be specified as normal to use that rule. Now let's go to question 3. Again, stop me if you want to work on it alone. The grade points average of the students in a large statistic class follows a normal distribution with a mean of 3 and standard deviation of 0.5. What is the probability that a random sample student from this class has a GPA between 2.5 and 3.5? Now we have, it's going from 2.5 and 3.5, and if you look at the mean and standard deviation, this one is equal exactly to the mean minus 1 standard deviation and mean plus 1 standard deviation. And so because it's a normal distribution, we can use the empirical rule to solve, and this one is actually 68%. So it's nothing difficult, just using the same rule again, but as long as you have to make sure that it has a normal distribution specified. There's an extra question asking, what will this probability be if the data doesn't follow a normal distribution? Well, the conclusion in this point, some of you might not think like they can ask this kind of question, but the answer can be like here, that nothing can be concluded. until the distribution is specified, or like until more information is given. So yeah, that's question 3. Now we're gonna go to question 4. What do you need to check before using the empirical rule to describe a population? Well, after question 2 and 3, you guys should know immediately what you need to check, which is if the population is normal. So it's gonna be B is the answer. Now, someone might argue about C, whether or not 68% of the population falls within one standard deviation of the mean. Now, if you look at the norm, if you learn later in statistics, and I would say it might not be the case, is that standard deviation, they can have 68% fall within one standard deviation, but no, the normal distribution will have this empirical rule, but it is not the general rule. So like you can have some other, maybe like populations, like you can have 68% here fall within one standard deviation, and you can still have like 68% satisfied, but it's not a normal distribution. So those are the things that you should check back, especially later when we learn about, if you learn more about statistics, you're gonna know things about like T distribution or F distribution. Then those things are gonna make our lives so much more difficult, but they sometimes can satisfy the 68% as well. So having said that, now let's go to question 5. We're moving really fast today because I think it's kind of like halfway overlap with last week on the data display, but for the rest, like the new thing is standardized score is kind of like just one concept, and we just have apply it a lot and try to understand all aspect of it. Now, stop me if you want to work on it alone. So we have below is a scatter plot of a car's gas mileage, mileage, whatever, I don't know how to say it, versus engine displacement from the EPA data for 2013 model years cars. We can see that these two variables. So now we look at the displacement and MPG in the city. Now look at the plot. It looks like most of them are going downward, and so it can tell me a fact that between displacement and MPG number, it can be like a negative relationships, and the trend looks like it can be very significant. So it can be from moderate to strong strength, and so and then the plot, it looks, I mean, just looking at this point cannot give me anything about this linear, or like you can fit a line like this in there, or you can fit a line like this in there. It doesn't really matter. Or you can just like ignore the outliers here and you can draw a line like this. It doesn't make much difference until we use we actually compute the line using software and all of that. So let's look at the answer choices. A has no association because the plot is not linear. Well, you don't know that. It depends on whatever you want to fit in and what is the value of residuals that we're going to learn later on how to like resolve that problem. Have a positive association, or have a negative association. D, not enough information to conclude. So based on this, A is kind of like 50%. You don't know. B is not right. It's a very clear negative association. So we're going to pick C, which is the answer, have a negative association. I mean, of course, if you want to determine A, you need more information. But C is a definite answer. There's a negative association based on just the scatter plot alone. So now let's go to question 6. The time series plot below shows the percentage of Americans who report exercising frequently based on 15,000 interviews conducted every month by the Gallup poll. We can see that the percentage of Americans reporting frequent exercise between January 8 and January 15. And it leaves something for us to view. So if you look at this, well, the trend looks like it's fluctuated a lot, but it does look like there's a pattern of to come back up. Yeah, it looks like a sine function when you go up and down like a lot of times. And then, so what we have is that I feel like it has a strong seasonal effects because it of the fact that you see that it keeps repeating at some certain period of the year. So like say here, you can guess that this part is going to be September 8th. And here you have like another, maybe like a few more months, it's going to be another September. And then it's also the same here. And you have another peak in another September. Then September, and then we have September. So it's around September, there can be some craziness going on. September, August, I don't know. But it does look like the percentage of exercise just keep increasing in this month. And also, if you look at the trough, it does look like they have certain periods to drop, and they kind of like quite consistent with one another. So A has a strong seasonal effects and little in the way of a trend. B has a strong upward trend over those 7 years and a negligible seasonal effects. Okay, there are two things wrong in B. Negligible seasonal effects is not negligible. It's really clear in this graph. And I mean, generally, I can see the fact that it's kind of, if you draw a line from here to here, it's kind of like showing us that it does go up, but it's not a very strong because it's very, very slightly. Like if you look at the slope of the line, like just go through most of them, it's just very small. So it's not really the answer. So B is not right. Has a positive association with temperature outside. Well, I mean, the thing here is relating between percentage exercise and temperature. But as I say, the no, not percent. No, they don't have anything related to temperature here. So C is also not right because it's asking about some other data that we don't have. And then D has a strong downward trend within those 7 years and a negligible seasonal effects. Again, strong downward trend, no, it's actually slightly going up. And negligible seasonal effects, no, it's actually a very strong seasonal effect. So D is also wrong. So our answer here is A. And so, yeah, so that's the answer for these questions. I think this is the last one that we have. Okay, question 7. Again, stop me if you want to work on it. Below is a histogram of the average rainfall in inches per year of the 60 largest city in the US. Minneapolis gets about 25 inches of rainfall per year. Its standardized score in this data would be, okay, if you look at first the distribution, it does look like we can fit in a bell curve here, and it fit really well, except for like something here. But just for the simplification of the model, and also if you look at the answer choices, there's nothing saying like more information and all of that. So we're gonna assume it's kind of like, so here, how some is that? Assume normal distribution. Because it actually fit quite well. Like if you have a very clear skew distribution, then this assumption wouldn't be valid. But here it fit quite well, so we can assume there's normal distribution. Now from here, you can see the fact like the mean value looks like it's somewhere. Mean is approximately 35, and so 25 is 10, 15, 20. This is 25. So it's asking get about 25 inches of rainfall. So standardized score is the value minus mean divided by standard deviation. Now the standard deviation kind of give me the fact that it's between the first interval of standard deviation is between here. But let's see our answer choices. So first of all, you have the value 25 minus 35 is definitely negative. So it can only be between B or C. So A and D are incorrect because those two values are positive. And now we look at it. 25 is slightly a little bit smaller than the first standard deviation. So I would say the value is between 0 and -3 instead of even smaller than -3, because that will mean 25 is somewhere around here, which is not right. So our answer is going to be C. So this is how you guys gonna interpret the graph, and also just like the level of expectation that you should see in this class. It's not too hard, but as long as you work on it and maybe like ask questions, that'll be more helpful. Okay, so I'm sorry. I kind of like just finished my session just now, so if you have any specific question, that'll be great. But I have no idea, like, because I don't feel like repeating what I just did is a very good thing to do. So just let me know what you want us. Do you have any specific questions? Hello, um, Danielle. Do you have any specific questions with today? Because actually I have my exam review this Sunday at 9 p.m. Not now. So if you're here for the exam review, then I'm afraid that you might have to wait until Sunday. Or if you're here for like less than 5 questions, I'll be more than happy to answer. But just let me know what you expected, what you want. Maybe like type it in the chat room or say it out or words. So some final notes. Again, this next section is Sunday. We don't have any other session next week because it's exam week. Yeah, try out a practice exam and also the extra credit to get more kind of like practice, and ask me any questions if you have them. So Danielle, if you have no, can you say something to me? Because I feel like I'm not like, I'm like, I need some interactions here to see if we're doing. Okay, so I am the only one left here, so I'm gonna end the conversation here, and I'll see you guys on Sunday. Have a great week working on